So thank you for coming out, everyone. So this talk will be about using features for developing Python programming, and in particular what I'm going to be talking about is there's this new PEP out by Guido that's all about doing async development. And it's kind of interesting. Before Guido started talking about this on Python Ideas, we were actually looking into doing async development for GUI programming, which is completely different from what the PEP is really about. The PEP is kind of all about doing async programming for doing low-level networking I/O and getting high performance there. So my team, I work at Microsoft, and we kind of, whenever there's some cool new technology that Microsoft is doing, we kind of like to come at it and see what we can do with that technology and with Python. And so one of the big new things that has come out recently is, of course, Windows 8. And Windows 8 has an entire brand new GUI programming framework. And a huge amount of that framework is actually all built around async interactions. And that's so that the GUI never blocks, it always remains responsive, and the user is never really feeling that frustrated feeling when their program kind of locks up and becomes non-responsive. And so we were curious, how would we do this with Python? One of our goals was to not change anything about Python itself. We wanted to work on an existing version of Python. We didn't want to have to drive new language features into Python in order to make that happen. And so we were really kind of thrilled that with the new features that already arrived in Python 3.3, that we were able to accomplish that. And Guido came at it from a completely separate direction, and it's kind of eerie how similar the two solutions are. So I'll talk a little bit about the differences. Guido's implementation is called Tulip, and our implementation is called Waddle, and it was mostly written by my coworker Steve, who is here and had a small talk earlier. And did a lot of debating on Python Ideas with Guido, and we kind of flushed out the idea from our side, and it's great that it all worked out that this one new feature that will hopefully end up in Python 3.4 will work, I believe, not only for network applications, but also for GUI applications. So, why async? This might be obvious to some people. First off, everyone's doing it. It seems to be the new rage. Of course, C++ has this stood promise, which is basically a feature by another name. JavaScript has always been very async by nature. In web frameworks, in web programming, you have lots of callbacks because JavaScript is single-threaded, and you're going off and doing web requests, and you don't want those to block the UI. And that kind of works great. You have all these inline anonymous functions that you use for the callbacks, and some people like that style, some people hate that style. With C#, which is a language I spend a lot of time in, there's this new async feature in .NET 4.5, which is very similar to what I'll show you today. And I think it offers the best programming model for doing async development. Users hate blocking. I kind of mentioned that a little bit before. It's very frustrating when your app's not responding, you don't know what's going on, it's not updating, and you just want to get your work done, and it's in the way. But async programming is also kind of difficult. If you have your GUI app, it has its single thread, which is processing all of the messages, which is typical for just about every single GUI framework that's out there. And if you go and do something that's going to take a long time, it's going to block the GUI thread, and the app's going to become non-responsive. And the way you work around that is you take code and you run it on another thread, and you have some signal that you post back to your event loop when it completes, and then you need to bounce back to the UI thread to update it, and keep bouncing back and forth between these threads. If you have one long-running operation, that's kind of okay. It's not particularly terrible, but if you're kind of have a series of cascading long-running operations where you're going to a website, getting some data, and then updating the UI a little bit, and then doing something with that data, going off to a website again, it really starts to get pretty painful. On the networking side of things, async is great because it helps people create highly scalable applications. And that's kind of the angle that Guido has been coming at it, and so Twisted developers should be pretty happy with the new PEP. You see it a lot in Node.js, where you have JavaScript running on the server, again, using callbacks that some people love and hate. And so it's good for that too, but I won't really talk about that anymore at all. So I think the best way to start this off is kind of give a quick demo of what the usual experience looks like today and what it'll look like in the future. So I mentioned Win8 at the beginning, and I don't have anything more to say about Win8. And so today, my demo is going to actually be using TK. It's the one GUI framework that ships with Python, so anyone should be able to pick up this code. I'll have a link to it at the end for the sample code. But what I'm going to show you will actually work with just about any single GUI framework that you're using, whether it's WX, PySide, or whatever. And I'll actually kind of have little pieces of information sprinkled through. And if you'd like to go off and try to make this with your GUI framework, I don't think it'll be too difficult. So this is my app. It's running on Python 3.3. So the Tulip implementation will land in 3.4, but there's no new language features that are needed to make it work. All my app does here is it has some code that's going to read in a very large text file. It's going to run through that text file and sort out the things that are just plain words. It's going to count all of the words, and then it's going to sort all of the words to get the top 10 words that are in the text file. Not a very complex thing, but it's 4 distinct stages where we need to do some work and wait for the result and then continue on. So if I click on, if I look here first off, you can see I've got the console running. I'm printing out some information as this goes along. We can kind of see this in the background as it runs. I'm printing out the thread IDs, and you'll see why that's kind of interesting in a little bit. But as I run this, you'll see that I'm going to be staying on the entire thread. So I click on count words, and you can see my code's running, but obviously my window is not doing anything, and now it's ghosted, and I've got the not responding here. And as a user, I'm rather frustrated. It eventually completes, and my UI updates with kind of everything that happened along the way. We were actually trying to update the UI along the way. We were sending all of the updates to the UI, but none of them showed until the code completed and the event loop got to run again. So that is just not a very good experience at all. So the way I might solve this usually is with this function here. And this could potentially be one of the worst ways to go about solving it. You could probably write some helper functions that might make it a little bit easier. But what I'm going to do is I'm going to spin up a thread pool. I'm going to submit some work to the thread pool. And then I'm going to add a done callback for when that completes. So far, kind of simple. It completes. I'm going to output the thread here. So this is where the threading gets kind of interesting. I get the result from the future, and now I need to update the UI, but I'm on the wrong thread. So the next thing I'm going to do is post some work back onto the UI thread, where I can actually go and update the UI. And this continues, right? So now I can update the UI here, and now I want to clean the words. So I'm going to submit that back to the thread pool thread. And guess what happens when the thread pool thread's done? It has a done callback, and I need to get back to the UI. And so I have all of these horribly nested functions. My code isn't reading very well at all. It's getting scrolled off my screen. Maybe I didn't have to use nested functions. Maybe I could have had these as top-level class functions or had another class to flow my state between them instead of capturing them in closures. But this is kind of a fairly straightforward way to do it, even if it's super painful. So let's look at that one running real quick. I'm going to replace the handler there, hit F5 and run it again. Again, we can see we start on the UI thread. I click count words. We see cleaning pops up, so my status is being maintained. My app is running. It's remaining responsive. And you can see through here, words loaded completed on a different thread. And then we've loaded the words, and we're bouncing back and forth between the threads. So I've solved my problem, and my user's happy. But I don't want to maintain that code. I don't even want to think about that code. When I look at that code, it's very hard to understand what's going on. So I'd like a much, much simpler way to deal with this. So let's undo that change. So we're going to do count again. Let's pretend that painful do account doesn't exist. And I'm going to go ahead and decorate this with a task decorator, which is going to turn this into a Tulip task. Whoops. The next thing I do is transform my long-running calls here into these yield from async calls. This async method is just a little helper, which is taking another callable and its arguments, and it's going to go off and run that on the thread pool thread, just because it's a little verbose to send it to the thread pool thread via Tulip. So, and I can pop down and look at that real quick. And so that's all this is doing, is it's getting the current event loop for Tulip, and run in executor goes off and runs that on a thread pool thread. There's one more change I need to make. So usually with any GUI framework, you start the event loop somehow by calling some method. With Tulip, we get a new event loop, which is Python's event loop. And normally in Tulip, this is just something which is processing network events. But here, we're setting up the event loop, which will let the Tulip framework know what the current event loop is so that we can get it back out later from arbitrary code. And then it's just going to go into TK and run its normal event loop. So that's a pretty simple set of changes, right? And my code reads almost exactly like I wanted my code to read. It's very straightforward. If I wanted to use loops in here or exception handling or any of the normal programming constructs, I just write them how I'm used to. And I can reason about this code. So now I hit F5. You'll see we start on thread 2968. We count the words. Cleaning shows up. My app's responsive. It's beautiful, wonderful. Not only are my users happy, but I'm happy too. So everyone wins. And yeah, so that completes. One of the interesting things here is that we're automatically bouncing between the UI threads and the worker threads in the thread pool. So you can see whenever I'm running my code, I'm automatically coming back to the UI thread. And so I'm not violating my GUI framework's single-threaded conventions, and that's great too. So my program isn't broken. So that's why I think this stuff is really cool. So there are a few core concepts in there. We saw the task decorator. And all that thing does is it'll drive forward our state machine, which is doing the yielding. We saw the event loop that I added at the bottom. And you know, the title of my talk includes futures, but strangely, we didn't see a single future anywhere within the code. Other than the submit to the thread pool, you didn't really see the future there, but that thing actually returned a future. And the way this works is in my generator function, which is what I turned that into by using the yield from's in it, futures are being yielded out, and it happens very transparently to the user. So the top level task is pretty important. It kicks everything off, and it's called just like any other normal function, and it gets tasks yielded to it. But the key thing about it is that it automatically steps forward as those futures complete. So the future is yielded out, and that future has a method called addDoneCallback on it. And so the task, it calls addDoneCallback on the future that's yielded to it. And whenever that task completes, or whenever that future completes, it's going to call back onto the task, and it's going to reschedule the generator, which is going to go off and run on the UI thread again automatically. And so that just lets this all just magically step forward as the futures that you're yielding complete. You can get futures from the thread pool. You can get futures by doing I/O with Tulip. And you could use your own futures to go off and do work in an async manner on your own, and then just set the result whenever it completes. Whether that's using your own threads that you're creating or whatever, it just gives this nice composable model. And so this is kind of what the task looks like. So it's just a simple decorator. It's going to call the generator, and that's going to give us the coroutine back, and it's going to create a new task with that coroutine. The first thing that's going to do is it's going to schedule that into the event loop with this step method here. And that's what actually drives the event loop forward. So each time step gets called, it's going to run one step and go through the code until it yields out some values again. So the features, I kind of described them a little bit, but whenever you need to do some async work, you can produce a feature. The thread pool already supports features. In Tulip, there's a new feature class, which is separate from the existing feature class that is shipped in previous versions of Python, but you can use either one within the Tulip framework. So you can yield out one of the old style features, or you can yield out one of the new Tulip features. And as I said, we call add done callback on the feature, and when it completes, we move it along and continue running the task on the UI thread. So the first time through, the first time we call step, we'll see if it's a feature, which it has to be basically. There's more code here that I've elided. And we'll add the done callback. And the wake up function will see what's going on if we got an exception from the feature because something off in the thread pool errored out, or if we got a value from the feature because something completed successfully. We'll go into step, and that will then re-raise either the exception or it'll give us the value back. The event loops. So this is kind of core to Tulip, and it's one of the big differences that we had between Tulip and Waddle. So for the GUI programming, the event loop mainly knows how to get back to the UI thread. It also knows how to do a ton of I/O-related stuff, and we don't care about that too much for GUI programming. In theory, we could just replace it all with work on the thread pool. But we can actually do a little bit better than that with event loops as well, and I'll talk about that in a minute. So Tulip mainly includes event loops which work with I/O. So it includes kind of two built-in event loops, one for Windows and one for Unix. The Windows one uses I/O completion ports. The Linux one uses select, epoll, kpoll, etc. Other frameworks are likely to ship their own event loops, which are going to schedule work into their existing frameworks so that you can start using yield from with those frameworks in order to create nice async code instead of using functions which are passed in as callbacks and so on. Right now, there's no pre-existing GUI event loops, but I have the TK one, and they're not really hard to create, as we'll see. And I think this lines up very nicely between the two because what Guido has tried to do with Tulip is keep this very single-threaded world where there isn't a lot of contention between multiple threads, which are slowing the overall system down. And GUI frameworks kind of work the same way, where you have a single thread, which is all processing the GUI events. So this is the Tulip Event Loop API. And you can see it's got a bunch of random stuff in it. It's got a huge amount of I/O stuff over here. You don't have to really worry about all of this stuff if you wanted to make an event loop. Those APIs are actually optional. So it's, not too bad. But for GUI programming, you can actually do a lot better. And I think those are kind of the only APIs that you really need to create a GUI event loop. And all of these other APIs can actually be implemented by delegating to another event loop, which is running on another thread. And so if you're on Windows, for example, you can have a bunch of I/O that you're doing, and that's completing with I/O completion ports using the normal event loop kind of nicely on one thread. Or if you're on Unix, it's completing with select on a single thread. And so all of your I/O is kind of nicely isolated and being processed by that single thread, and your GUIs remaining responsive as well. And so I have some sample code. I have a link to it at the end here, which has kind of a base GUI event loop implementation, and it actually implements all of this stuff. So if you wanted to go off and write an event loop for WX Python, you just have to implement these run forever, run once, stop, call later, and call soon APIs, and you get everything else for free. So these are actually really pretty easy APIs to implement for your event loop because they really line up very closely with primitives that almost every single GUI framework has. So run forever. Well, that's just your main event loop. So you can do app.mainLoop in TK. WX, it's really different. It's app.mainLoop main loop. And PySide, app.exec. So run once. It's pretty typical for GUI programming frameworks to have a way for you to pump messages, so you can have all of the problems of reentrancy. In TK, that's app.update. I couldn't quite track down what it was in the other web frameworks. If there's any .NET WinForms programmers, it's application.doEvents. So those all exist. I'm sure there's one for WX and PySide as well. I'm not a WX or PySide developer, so I couldn't find it. Stopping your app. Every Windows GUI application has a way to quit, right? So if you want to stop your event loop, there's some way to do it. So app.quit on TK. If you use other frameworks, I'm sure you know what it is. And then the two final APIs are call soon and call later. And so this is to post work back into the GUI's event loop. Call soon just means kind of run me as soon as possible, right? And so it's just sending a message to the event loop. And in TK, you can do that with a delay pretty naturally. And you just pass in a callable. In WX, there's a call after method, which schedules the work on the UI thread. Call later can potentially be a little more interesting. TK actually has a way to do it where you can pass in that delay. So it's very easy to do for TK. WX and PySide both have timer classes that you can use. And those timers can have intervals, and they can be scheduled pretty regularly. If we go back, there's also this call repeatedly API. That can be built on top of call later pretty easily, where you schedule the work to run later, and it runs, and then you reschedule it to run in the same interval later. You could do slightly better on WX or PySide, where you actually have these timers which will run repeatedly. So that's kind of the basics of how it all works, how you can build an event loop, and how you consume it. But I wanted to talk about the internals of it and what it builds on in Python itself, because I think that's kind of one of the really cool things here, is that this is basically done without changing the language at all and just using the existing features in the language. So the first thing that it uses is generators. And the important thing here is that generators kind of hoist everything into a state machine for you. And they move all of your locals off the stack, which in CPython is kind of already done anyway, but it conceptually does that. And it allows you to suspend and resume the execution of the function. And it just turns out that Python generators are just super, super powerful. I don't know of another language that has generators that are nearly as powerful. So the first building block here is the fact that generators got the send method in 2005. And so that lets a generator actually get a value back from a statement that has been yielded. So if I call this generator and call next on it, then I can send a value in. And that lets me use these as expressions, get values back. So when I have a future that's returning a value, back that value comes via this same mechanism that has existed for 8 years now. One of the most important things, though, is a rather recent development, which is in Python 3.3, we got yield from, and we got generators that can return values. And the way this works is when the stop iteration exception is raised, it's actually raised with a value that's coming back. Before Python 3.3, it was an error to return a value from a generator. So this lets us actually write functions, which are tasks or coroutines, and have this return 23 come back from that value so that I can very naturally write something that's both yielding out values and suspending itself and producing values. And then finally, there's yield from. So yield from was kind of one of the big differences between Tulip and Waddle. We were just using yield, and in Tulip, it's using yield from pretty consistently everywhere. You can actually get away with just using yield if you just wanted to yield a feature, but you probably want to forget that and just remember to always use yield from everywhere. Features are iterable, so you can do yield from on them, and you just have to know this one concept and not have to get confused about, do I use yield or yield from here? And then features. So Python shipped features before. They've been in the thread pool. But PEP 3156 adds a new feature class. It's got the same basic API as the existing feature class. There's some few differences. You can't wait on the new features, but you can set the result, get the result, and it's if you've used the old features, you'll be pretty familiar with the new features. The old features were also a little tied to the thread pool. They had some internal APIs to kind of set some initial state on them, and the thread pool interoperated with those internal APIs. So the new features are kind of much cleaner in that respect, in that they're a simpler API and they don't have these internal details. The key thing about features is this add done callback. So whenever a feature completes, you call set result or set exception on it, or you can cancel it. And that will then go back and look at all of the callbacks that are registered with the feature and run them. And that lets us continue on. And we register with the add done callback, and your generator continues stepping automatically. So that's most of what I had. I have some sample code up, which you can download. That includes a GUI event loop. You can get Tulip as well and try this out on Python 3.3 today. The GUI event loop looks like this. So if you have a framework that you'd like to light up and try this stuff out with, you can take this GUI event loop, and then all you have to do is derive from it and implement those few methods that I've mentioned before, run forever, run once, stop. And you can see this is really not difficult at all. The only marginally difficult thing is maybe canceling events if you wanted to support that. But it's 62 lines of code to implement an event loop for TK. So while one might not exist for your web framework, I'm sure you can code one up in no time at all. Questions?
Hi. You implemented TK event loop,
Yep.
Which process only TK events.
Yep.
Usually, programmer need to process network events also in the same main thread. Both GUI events and network activity.
Yep.
How do it?
Is there a reason why you need to do it in the same thread?
No, just because usually I have signal processing, Unix signals, and often main loop, network loop assumed to be executed in main loop. Not in just auxiliary thread.
So that's kind of difficult because the GUI framework would need some support for processing those events, right? Which really for that to work means that the GUI event loop would have to be based upon select or epoll or kpoll on Linux or on the Windows event, Windows. I don't even particularly know how you'd combine those two on Windows into a single event loop. If you could get off the other thread, the way you would actually do this is you'd be using this other API here. There's getAtterInfo, for example, which returns a feature. And so you can yield from to the current event loop's getAtterInfo implementation. And the GUI event loop is actually going to defer to the IO event loop, and it's going to run off on another thread. And when it completes, it's going to come back to the UI thread. So I don't know exactly why you would be bound to needing to do all the IO events on the same thread, but this, it it would seem logically like they were running on the same thread, even though the blocking on the I/O would actually happen on another thread. But it'd give you a very straightforward programming model. So if you could somehow move that off of the GUI thread, then this would simplify things for you. But I don't know if you will be able to do that.
Thanks.
You mentioned several toolkits, GUI toolkits, just like WX, Qt, and all these things.
Yep.
Did you also make some tests with PyOpenGL?
No, I did not.
Okay.
Very interesting talk, by the way.
Thank you.
So my question is, and this is more of a Tulip or futures in general question, is how tied is it to threads as the concurrency primitive? Could you build something like Tulip or use Tulip for something like G-event or processes or some other concurrency primitive besides threads?
I think so. So it is, the API is single-threaded as it's documented, and so it isn't too concerned with threads itself. It has one API, which is like call soon thread safe, which is the only thing that really gets close to threads. The difficulty there, there's a bunch of these I/O-related APIs that are going to take sockets and things like that, and so if you wanted to go multi-processing, that's probably not going to work so well unless you invent your own system of handles between the processes and things like that. But conceptually, you could probably do that. You could have sock connect implemented in your event loop, I would think, that returns something that represents a socket in another process. And then when someone goes sock receive, you can handle that yourself, right? So Tulip uses transports and handlers and things like that to actually abstract away kind of the low-level details. I hear Guido's keynote will be more about Tulip, so you might want to attend that as well.
Thank you very much.
No problem.
I'm sorry if I missed it, but in the standard library, there is concurrent.futures and stuff. So I didn't see any references, or did you and build on top of it, or like? So what's the difference?
It's a brand new features class. It looks almost identical. The concurrent features is a little tied to the thread pool, and so it isn't perfectly reusable for this purpose. So there will actually be two classes called future in Python 3.4 when the PEP is all done, apparently. So. Nothing else? Thank you, everyone.